Thank you so much for coming through. I'm going to go through quite a few workflows for using ES6 modules in Node.js in the browser today. It's 6 workflows in total, and these workflows are very new. So it's great to be able to share this with you guys, hopefully getting more people using it. But it will go a little bit quickly. So my apologies in advance if I'm going too fast. The goal is really to just get as much as possible an overview to people so that you can see what is and isn't possible today. So I'm going to start off with the question, why are these workflows useful? And I think it's pretty good that most of you probably know what ES6 modules are. The main reason that I find them useful myself comes from this situation we have with modules in the browser today. And we've got these 2 very separate schools of thought. On the one hand, you have Browserify and techniques based on CommonJS. On the other hand, you have the browser and Require.js and AMD. And you kind of have to pick one or the other for a project. And having made that decision, you have to kind of stick with it for the rest of the project. And you can't really make the 2 systems work together very easily. So we've got this kind of fragmentation in module systems at the moment. And you kind of have to use one system or the other. And I just find it very frustrating. So the goal with, if you do want to make them work together, we've got something like this monstrosity to try and merge the 2 together. So it's a very difficult interop that we have. So for me personally, I got interested in ES6 modules because it's a way, hopefully, that we can move beyond the fragmented module systems we have at the moment and have a single, stable, spec-compliant module syntax that we all can use and write modules in one way. So it's kind of this ideal, this vision that hopefully we can get out of this fragmentation at the moment and work towards something like this. And the point is with the specification, the ES6 specification enforces a consensus for all of us. So by getting that module specification, we're all on the same page, and we can go ahead and actually start writing and working with modules and get past these kind of debates over which way of using modules is best. So that's kind of why I got interested in using modules. And I'm now going to pretty much dive straight into the workflows. And the main tool I'm going to... first, I'm going to explain the actual specifications and what is and isn't covered by the ES6 module specifications. So there's 2 main things that the ES6 specification covers. The one is the module syntax. So this is the import syntax, the export syntax, probably what a lot of you have already seen. And then the other thing is this module loader as well. So when the browser actually interprets the import syntax, the JavaScript engine then knows how to deal with that, how to load a module, that loading pipeline behind it, how to deal with circular references, how to deal with bindings. And this is defined quite deeply in the module loading pipeline of the module loader, which itself is actually in the ES6 module specification. So that pipeline's defined. But that module loader can also be made available as a global in the environment. So I can make dynamic requires through that module global. So it's a single module loader object. There's also the ability to have environment configuration for this module loader. So the specification determines how the loading pipeline works and all that sort of stuff, but it doesn't determine everything to do with the module loading. So it leaves these loader hooks for the environment to individually specify how to load modules. And then there'll be this separate browser specification. For the system loader is what it's currently set to be called in the browser. So this will be the environment loader of the module loader that's specified in ES6, determined in the browser. So just to give you an idea of these specifications, the module syntax has been drafted, it's in the spec, and it's been reviewed quite a lot. It seems relatively stable at the moment. The module loader itself has been drafted into the spec, but it still needs to be properly reviewed, and that's going to be happening over the next, I assume, 2 to 3 months or so. And so that's where we're making progress at the moment. The separate browser specification determining the exact behavior of the system loader and how loading happens in the browser, so those environment settings. This is something that's currently just based on a pseudo implementation based on Mozilla project. So there isn't actually a formal specification for this yet. And that'll be the next step after the ES6 spec, is determining these formal specifications to get the system loader in the browser and a corresponding loader for Node.js that can provide a route forward for CommonJS modules. All right. So now diving into the actual workflows. The main project I'm going to be using today is Tresor. And this is a Google project that is pretty ambitious in the way that it tackles combining ES6 into ES5. So it's very active at the moment. It's a relatively well-maintained project. There is also the Square ES6 module transpiler. The reason why I'm using Tresor is because it's easily supported in the browser, and it's got a lot of nice features. And because of the fact that you get access to all the ES6 features as well. So instead of just using modules, I can actually also use ES6 class syntax and start playing around with generators and use other nice things along with using modules. In terms of the support, I had an interesting discussion with Yehuda Katz last night, actually, about this project versus the ES6 module transpiler. And I was really hoping he wasn't going to ruin everything I was going to talk about today, but luckily he didn't. And basically, with the Square ES6 module transpiler, they're going to try and support circular references and a lot of those deeper functionality in modules, whereas Tresor doesn't support circular references. So there's these kind of differences between projects. But this is the main project I'm going to be showing you today. All right, so I'm going to go through 4 quick demos of how you can use it to use modules in Node.js today. These are static workflows, so they're based on compiling ES6 with module syntax into something that I can use in existing environments. So I'm starting off in a demo directory. I just have, I'm just going to start writing a 2-module application. So the idea is that I'm going to have a main entry point that's going to then load a separate module. So I'll write the module first. And we just want to export a very easy test to just be sure that we're getting that export out. So this is how you do exports in ES6. I'm not going to go into the details of the syntax today. I mean, there's lots of information available, and it's going to be something that's relatively easy to look up. The goal is to show you what is and isn't possible, give you as much as possible an overview. So here I'm exporting a single name variable called test with the value ES6. And just like in CommonJS, I do exports .test equals ES6. It's the same kind of idea. So now I can load this inside the application. So I say import that named export test. And then just like CommonJS or AMD, I load it with a relative module identifier, and I call it module without the JS extension. The exact way that I write that module name is determined by the environment loader, but this is the general convention that's going to be supported. And then just to show that it's working, I'm just going to log that. So we've written this 2-module app. How do I now run it and make it work? So the great thing is Tresor provides us with an actual entry point that we can use to run a Node.js app using ES6. So if you install it with mtu install g Tresor, it's always EU. I always forget that. Once you've got it installed, you get the command line tool, and you can just run the app. So I'll just say Tresor app. So what that does is it compiles the ES6 into ES5, does the module loading cycle for me, and it loaded from the app, which loaded module, and then it showed the right export. So I'm using ES6 modules. It's pretty simple to get going with, and a nice way to kind of experiment with ES6 syntax as well. In that same app, in the module, I could have exported, for example, a class as well. Again, I'm not going to worry too much about syntax. And then I'm just going to initiate that as well. So I'm going to import the test and the class that I just exported, and then just instantiate that class. All right. So now I'm using an actual ES6 feature, ES6 classes. So if you just use module syntax without ES6 classes, you don't need to include the tracer runtime in your apps. As soon as you start using ES6 features like I've done, I now need to make sure that whenever I'm using this, I have the tracer runtime present in my environment. And the reason for that is that classes, when it compiles the tracer, uses a create class helper, which it expects to find in the global. So I can run this again, and it doesn't work. Did anyone spot the issue with my module syntax there? No. Sorry? It says what? Missing it? Semicolon. Oh, perfect. Does anyone know where that semicolon is? Okay. Export. Where is it? No ideas. Last line. Oh, I put a. Is that? I think I did my class syntax wrong. Yeah, sorry. Well, okay, I'm glad I worked that out. All right, so we've got the two things running there. So I've got class and ES6. Excellent. So let's hope the other demos go a little bit better than that. Okay, so this is all well and great, and I'm using the ES6 syntax, but how am I actually going to distribute this as a module to users? If I want to actually put this on NPM and get other people playing with it, it's not going to be very good if it's using ES6. So what I can do in this case is I can compile that entire application directory into CommonJS. And the way I do this is with the directory build option tracer. So with the --dir, I can say build all the modules in app individually into a module in the app build directory that is CommonJS. So I'm just going to say modules equals CommonJS. And that'll tell Tracer how I'm wanting to compile modules. So with that, I can now look at app build. And if you look at the app, you'll see it's now compiled it into something that can be understood in existing Node.js environments. If you look at the class one, you'll see it's using that tracer runtime helper. So if I hadn't used the class, I wouldn't need to include the tracer runtime. But now when I give this to users, I have to make sure that they're also including that tracer runtime. So how do I run this in Node? If I hadn't used the class, I could just run node app, and it would work fine. Because I need the runtime, I'm going to have to require that in a separate index file. So I'm just going to load the runtime. And then I can require from the app. So I'm just going to run that with Node. And it doesn't work. Okay, I needed to load from the build folder. Sorry. So there you see the same application now running in Node.js compiled into CommonJS. So in this way, I can actually write an application using ES6 module syntax, ES6 syntax as well if I wanted to use all the fancy stuff in ES6. And I can then actually build a project that I can distribute on NPM and use as an actual Node project. All right, so that's Node.js. What about the browser? So if I wanted to build this for the browser, we have this out option in Tracer. And what this will do is it'll build the entire application into a single file that I can include in the browser. So I'll build it starts, the first argument is the build file itself. So I'll call it app-build.js, and I'll build app. I don't need to set any module options because the default in Tracer is enough to make this work. And if I want to load this in a browser, I need to, again, include the Tracer runtime first, and then I can include this build file to make it run properly. First include the runtime. And then I can include my build. And with some luck, that should show me the same output in the browser console as we were getting in the server console. So I'm just going to load that up here. All right. So you can see there it's running it in the browser. So it's compiled it into ES5 and it's running in the browser environment. All right. And then the other workflow for the static workflows, just to finish these off, is this is all well and great, but I'm loading this single file. It's kind of this proprietary tracer bundle format, which isn't very useful if you want to do other stuff. If you have like a Require.js project or an existing project, you want to use modules with that, a good thing to use is AMD. So just like I did the CommonJS compilation, I can do an AMD compilation, and that then allows me to use the modules with Require.js, or I can use the Auto.js optimizer and make Require.js bundles. And that's exactly the same as what I did with the CommonJS compilation. So I use the dir option, I build app to a built version, and I say modules are AMD. And now I've got AMD modules that can be loaded in any AMD loader and used in the browser. So that's a workflow that can get me running in the browser. All right. So those are the static workflows, and it's very much geared around the idea that we have this application that we're writing in ES6, and we want to compile it into something in ES5. The other thing we have is the dynamic module loader. So just bear with me on this. I hope it isn't too much to go through in one talk. But the system loader that we get in the browser, which allows us to do dynamic loading, the reason why it's useful to use ES6 syntax already is because, as I said earlier, it allows us to get past this fragmentation we have at the moment, which is you want to start writing modules in a way that's actually going to be hopefully stable for the future. And the same justification for using that syntax, it can be worthwhile using the dynamic module loader as well, so that you're using a dynamic module loader that's also based on a specification. And that's the system loader in the browser. And over time, as the spec becomes more and more stable, this is going to be a more and more interesting use case. So just to show you the kind of thing I'm thinking of, any large application will load some scripts, but then later on, after the original page load, you want to load new content. So typically you'd have a loader that does this. And by using the system loader, you get the spec version of this, and it has an import mechanism. It works pretty much as you would expect. It's promise-based, so you just do a thenable, and you get back your import value. And the benefit of this is that it shares the same module registry with the normal import and export syntax that I might use inside a module tag. So effectively, when you write the module tag, and I'm glad Brendan Eichel explained it this morning, because I was actually only going to devote a few seconds to it. But when you use the module tag, it's actually in the background using the system loader. So it's sharing its registry with the system loader. And what that means is when I load this new content later on, it can share dependencies with what was originally in the page. And the benefit of that is you have this shared module registry. You're not having to reload extra stuff, and you're doing it in a kind of a spec-supported way, hopefully. So that's again, this is the ideal. So how can we work with it today? Well, this is a project called the ES6 Module Loader Polyfill. It's available on GitHub. And what this allows you to do is recreate that system loader in the browser exactly as it's specified in the ES6 specification at the moment. And I'm just going to show you a very quick demo of that using the same example we've been looking at. So what I need in the project is I have a tracer there, and I also have the ES6 module loader located from the GitHub repo. So it's just those two JavaScript files. And now if I want to create a browser application that's going to load the same two-module app that we have, I can actually now do all the transpiling in the browser dynamically with the polyfill. So I first include a tracer because I'm going to be doing the transpiling in the browser. I then include the module loader polyfill. And then I now have the system loader defined exactly as you'd expect to see it in the spec, which allows me to now import modules using that promise-based loader. And I'm going to import from the raw ES6 version. So this is the version that directly was using module syntax and class syntax. And the hope, again, is when I open this, it should show exactly the same console log that we have here at the moment. And it doesn't. Okay, you need to be running this on a local server. So I just run Chrome with the flags to allow file access from files. Alternatively, you can run it on a server. So I'll just load that up again. All right. Okay. So you see both logs. Yes, perfect. So it's loading the two files. It's transpiling them dynamically in the browser, and it's using the system loader to do it as based on the spec. So that is the ES6 module loader. And now this is probably the trickiest part of the talk. So you're doing very well. Thank you. So the idea is this. I want to be able to use the system loader to do requires, and I want to be using ES6 syntax so that I'm kind of doing everything in a spec-compliant way. But I need a workflow for this that's actually going to be able to work in production. So I need to be transpiling that ES6 into ES5 because I don't want to be doing the transpiling in the browser. And I need a way then of having an initial script that will pre-populate the module registry of the system loader so that I don't have lots of separate module requests. Because if I just did everything into AMD, you don't want to have lots of requests. You want it to be performant and be able to create bundles. And there's two ways we can do that. But before I can show you them, I have to show you another project. And hopefully I've got my slide order right. Yes. So, okay, this system loader has a powerful extension mechanism. So it's designed that you can actually load AMD modules, CommonJS modules, and global scripts in the existing system loader by adding compatibility layers into it. So it's a mutable loader. The system global can be effectively patched with compatibility layers to load AMD modules. And this is a very powerful extension mechanism, and it's basically the way in which the ES6 specification has opened up the loader to allow developers to actually solve the real loading problems. And a project I'm going to show you now is called System.js, which basically consists of a number of extensions to the existing module loader. And these extensions are available as separate patches. So, for example, if you're familiar with require.js or map config as a concept, if I just wanted to add map configuration to that core browser system loader, I can use a patch like this. And I can just copy and paste this code in after loading that system polyfill, and I'll get map config in the loader. And that would be a syntax, something like that. So it's these separate patches. You can apply them individually or together. And it's everything from formats, map configurations, version support, a plugin system kind of like require.js, and then a bundle system. So I'm just going to use this because I want to be able to use some of the compatibility layers. So, all right, I'm going to show you two quick dynamic workflows, and then those are the workflows. So. Demo. Dynamic. All right. So for the dynamic demo, I'm starting off with Adi Osmani's To-Do MVC project, and there's a version of it called Traceur To-Do MVC. So it's basically a two-module app, just like we've been looking at up until now. So it's a main app entry point, and it's using ES6 modules and ES6 functionality. And then there's a separate module which is just loading, which also features ES6 exports and lots of other stuff, classes, and destructuring various features. So firstly, what I can do is I can use that initial mode I was using just now to use that system polyfill in the browser, transpile in browser, and just be loading ES6 modules and ES6 syntax directly into the browser. So in the index page, it's just got some general styles and markup. And what I need to include to actually get this to work is, just as I did in my previous demo, I first include Tracer because it's going to be compiling. Then I include the ES6 module loader to give me the system loader. And now I can directly import that ES6 and that ES6 syntax. So let's open this one up. All right, so there's the to-do MVC example. And it's compiled all that module syntax, and it's all working correctly. So, all right. So the question then is, let's see that production workflow now working in this scenario. So I'm going to use the single file build mode first from Tracer. And what I'm going to do is build this JS app into a single file using the out option. And I'm going to build it into a file called jsbuild.js. So it contains JS app. And I'm going to use something called modules instantiate. Now what this is it's a shared module bundling output that can be understood by the system.js extension to the ES6 module loader. Does that make sense? No? Okay, let me show you exactly what it looks like. So it's built it into the single file with these system.register calls. And this instantiate output creates system.register calls that can be understood by this patch in system.js. So there's a module in system.js called system.register. And what it does is it creates that system.register function and then tells the module loader how to understand that register function. So it's just a small little patch that says when you see a system.register call, put that module into a cache for the module registry. So basically that's the only patch I need to get this version of the demo to work. But I've included the whole of system.js just because it's easier. Does that make a little bit more sense? Potentially. Okay. All right. So I'm now going to load into the index. I'm not doing the compiling in the browser, so I only need to load the Tracer runtime. And that just gives me my class helpers. I load the module loader, and then I can load from this build bundle. And now when I do this import, it's not going to send separate requests and load the modules in the browser and transpile them in the browser. Rather, it would have already pre-populated the module registry with those modules so that they're already defined. So when I do that import, the modules are already there, and I'm not actually initiating a request, I'm just getting it back. All right. And so with some luck, that should work. Wrong example. So there you go. Actually, it's still done the separate requests, which means that there's a bug. Did anyone catch it by any chance? I didn't save. Oh, thank you. Okay, perfect. Saved me a lot of time there. And now we've got undefined is not a function. So I didn't actually load system.js in either. So it didn't. When it tried to do a system.register call, it got an undefined. So I should have caught that one as well. So I'm going to include system.js. Yeah, so that's the kind of order. It's Tracer, module loader, system.js. Okay, in terms of size, sorry. The module loader is 15 kilobytes. System.js is 12 kilobytes. So you're getting this sort of 27 kilobyte production loader. Various builds of system.js can get down to 6 kilobytes in production. So you can end up with an under 20 kilobyte spec compliant loader in production, potentially. Sorry? That's minified, yes. Yeah. Not gzip, just minified. All right, let's hope it works. There you go. And didn't do the request this time. So it's loading just from that one script bundle. So it's one network request, populates the entire module registry, and then I'm loading this app. So that's kind of a production-suitable workflow. I'm going to show you one more very quickly, but I'm not going to go into all the details because we're running out of time. But just like I did AMD compilation earlier, I could have also done the out build and I could build JS into a JS build folder and say modules equals AMD. I can then use something like the require.js optimizer to optimize that JS build folder into a single file. And then system.js supports loading CommonJS and AMD directly. So the system.js loader, actually I might as well just show you. So at the moment I've got JS build containing separate AMD modules. So I'm just going to load directly from those AMD modules using system.js. So I'm not going to include the bundle anymore. I'm just going to load from JS build the AMD versions. I've got runtime in because I'm still using ES6 functionality. And system.js is now giving me AMD support in the loader. And just to be clear that I'm loading AMD, did I even make that? Sorry, it's the dir option. Sorry, the dir option is the one that compiles all the modules in one folder into another folder. So now I've got this JS build directory, and these are separate AMD modules, and I can now load these directly into the ES6 loader. Let me just reload this. Why is that not showing me network requests? I did what backwards? The out option writes the output bundle first. The dir option writes the input directory first. So it's a bit confusing. Sorry, Trace is very badly documented as well. So there's another reason why I wanted to show you these exactly. That dir option actually isn't documented anywhere at the moment. It's on what? Sorry? Oh yes. Okay. All right. Let's reload that. So there it's loaded 2 AMD modules, which have then populated the module registry of the system loader. I've then done an import, and I've got the app functioning. I could use the optimizer to make a single bundle. Name defines are also supported. So that's a production workflow as well. So AMD is the ideal target for ES6 for getting it to work in existing environments and ES6 loaders with an AMD compatibility layer like system.js. All right. So those were the dynamic workflows. I'm just going to quickly explain sorry, I know it's going over a bit, what the options are for bundling. We have system.define, which is an entirely comprehensive bundling output for ES6. But the real goal for ES6 is protocol-level bundling. It's technologies like SPDY. And there's also a zip URL, which allows you to kind of compress modules into a single request, but at the file level using an HTTP add-on. So I wanted to show you a very quick demonstration of JSPM, which uses some of these bundling ideas for SPDY and shows you some of the possibilities when you start to consider package management around these ES6 principles. And basically, I can take that system, so it's built for the system.js loader, and I can add some paths to it to automatically load from GitHub and NPM over CDN. And the idea behind it is, well, we're in the browser. Why do we even need to download modules locally? If we've got this multi-loader that can load CommonJS, AMD, globals, it's kind of spec compliant. So then we can just load things directly off CDN. So just to quickly show you a demo of that. So it hosts system.js, which is built, it includes the ES6 module loader, so it's that same system loader, hosted on CDN. And then I can just directly import common libraries. So in this example, I'm just going to import jQuery. And that's all I need. I don't need any local files to make this work. When I load that up, you'll see that it's loaded jQuery dynamically. So you see there it's loaded jQuery, and there it is. I could also load some jQuery directly off GitHub. So in this example, I've just said jQuery. It's had to go to a registry and work out that that's on GitHub. I can directly load from GitHub components jQuery. So this will say, go to that components jQuery repo on GitHub and directly load the jQuery module. It's a CDN in front of GitHub. It's fresh. It'll use the latest stable version and make sure that that's up to date. And that'll work exactly the same way. So there it is. Because the loader can also load common JS modules, I can do exactly the same thing, but for NPM. And jQuery is now on NPM, so I can actually just load it directly through. A lot of Browserify modules will work like this pretty much directly. So there you see it. Straight off NPM, it's just loading it through a CDN. Just to give you an idea of what's possible with all this, here's a music app built directly off of GitHub CDNs, NPM CDNs, being served with Speedy Push, using the system loader on top of the ES6 module loader polyfill. This is loading from a fresh cache. And I can kind of add these music plugins into the page. So this is sort of production use of an ES6 module loader. And there's an audio out over there. So I can kind of link together audio tools. As I loaded that audio tool onto the page, it dynamically loaded it with the system loader. And then you can kind of get different audio functionality together. So just to show you what's possible when you look at some of these ideas. All right, that's it. Thank you very much. Appreciate it for your time.